see the roadmap here. We have finished univariate, bivariate. Yesterday we were supposed to do this, but due to some reason I was not available. So today we'll finish it off this. Okay, if time persists, we'll do this, or else we'll park it for next week. Monday and Tuesday we'll finish these two topics. Okay, and then we will start working on sample data. Okay. So this is EDA 11, 12. Okay, so I just renamed it with multivariate analysis, EDA. Okay, so these are all the steps that we have to follow. Okay, if you see this roadmap, these are all the steps. Now we are here, so we'll study more than two variables relationship. Okay, with heat map, pair plot, and PC for advanced learning. Anyway, we'll cover this. PC stands for principal component analysis. Okay, I'll brief this in the machine learning because this is very important. I'll tell you why this is important. Okay, so let's get back to our this thing. So what is multivariate analysis? It what it does is it studies the relationship among three or more. Okay, initially we started with one variable analysis like age, group, age, marks, and all, right? Those are one column. And later on we did bivariate comparing to marks and score, if you recall. Okay, now we will pick up the analysis studies, I mean the overall relation among three or more variables. Okay, whenever we say three or more, it could be five, it could be six, it could be eight, nine. If you have 10 columns in a Excel sheet, okay, so you can do more than five, 10, or whatever. Okay, or the entire this thing also you can do 10 columns. Okay, so multivariate is more than three. Okay, generally more than three. And to understand, so what is the agenda here? What is uh, the uh, uh, agenda here is to understand interaction, then dependencies, okay, and the hidden pattern in your data set. Okay, so that is the agenda here. That's our objective for today. Okay, I'll just run this. Okay, so this is the multivariate analysis. It's the study uh, the relationship among three or more variables. Okay, to understand interaction, dependencies, and hidden pattern in complex data. Whenever you have 20 rows, 30 rows, right? Sorry, 30 columns, not rows, columns. Okay, so somewhere the data pattern is hidden. You need to bring that out. And how that is possible? Through multivariate analysis. So what is what is multivariate analysis? Okay, simple. It involves three or more variables. Okay, say for example, in the previous one we have seen how marks depends on study hours and gender. So now here we are talking about marks, study hours, and gender. Okay, what is the purpose? To understand the interaction, dependency, correlation. Okay, all that you can do. And what are the common tools that we have to perform this multivariate? One is heat map, pair plot, facet grid, 3D plots, and PCA. Okay, we'll try to finish it off today. Okay, so this is a type, description, and example. Okay, so three columns. Okay, now I'll create a data set. So earlier we have seen the same data set, name, gender, stream. Okay, study hours and marks. Now I'm taking something called attendance. Okay, if I want to do multivariate analysis, attendance, if you see the attendance of this person, how often they are taking leave or how often they are attending classes and all. So there is a sample numbers are there. Okay, I'll run this and let's see how the data looks like. It's the same thing. The previous one, the one which we did, right? Same thing. I just added this column alone. Okay. Yeah, there's my data. So you see here, if you type df dot info, you can see these are object 1, 2, 3. Stream, gender, name. Stream, gender, name. Okay, these are all categorical data. Here, integer, study hours, marks, and attendance. These three columns are, so we don't do any changes here. Okay, all looks good. Integer, data is integer. Okay, sometimes you'll see object also like date, time frame if you recall. Okay, so first you run this command, see uh, what kind of data type is assigned. Okay, or these rows looks like. So you'll get an idea. Okay, I'll just add few cells. Okay, so first thing first, what we'll do is we'll run a pair plot. Okay, how do we do a pair plot? Cborn. Okay, see, I'll take the pseudonym of Cborn, which is sns dot uh, pair. Yeah, pair plot. I'll pick the pair plot, and here we have to pass the data. So what is my data? Df. Okay, data frame, everything is in df. Df, then hue. Okay, hue means which column I want to bifurcate all my data. So I'll take here, name is there, stream is there, so male female is there, right? I'll take gender. Okay, I'll take gender. Okay, I'll take diag. Okay, this is the parameter that you have to type. Yeah, I've already showcased all this in previous one, KD. Okay, so this KDE. Okay, these are the parameters. Okay, now if I want to see the data, okay, I'll type plt dot show. Okay, I'll run this. So this is my pair plot. Okay, so gender is my common hue here. Okay, and complete data it is showing. Okay, now you see here it is going this way, it's not linear. Okay, so female is this uh, blue dots represent a male. Okay, now you see here attendance, whose attendance is perfect here? Females. Okay, they are tend to be more punctual to school. Okay, or college. So average, on an average, there are close to 94 scale. Okay, 94%. But female above 96, 95 or 96 or 97 or 99. Okay, marks. You see marks, who is scoring marks? Male. Okay, and study hours, who is spending more time? Male again. Okay, so each diagonal that it is represented here shows distribution, KDE. So this one, KDE. Okay, if I remove this one property, okay, nothing is happened. Okay, but earlier the clarity was good. Okay, I can see some blurry image. 1 minute, I'll just add that. Diagonal kind is KD. Yeah, now it looks good to me, because I don't know you guys identified that or not, but for me earlier it was looking like a very blurry. Okay, so now here, this is a marks column. You see here more boys are leading here, and this column is what? Marks. Okay, marks also, if you see, female. Okay, and here, what is this? Attendance. Okay, no, sorry, marks. Okay, marks here, male are dominating, and attendance, uh, females are dominating. Okay, and you can see the color separation also very important. Okay, this color separation, then only you can identify. Right now we have only uh, study hours, marks, and attendance. Why? Because these are all numeric data here. Okay, if you have one more numeric idea data, it will show one more value. Okay, one more row you will get for that particular label. Okay, now we'll do a heat map. Okay, same thing last one which we did. Correlation is equal to DF of study hours, marks, and attendance. I picked up these three columns which are numeric, and I'm using a correlation function. Okay, and then I'm creating a heat map, and I'm passing this value here, CORR, annotation true, C map cool हुआ मतलब cool हुआ means color pattern will be cool. It should not come like a dark red, dark yellow. So it should be a very soothing to your eyes, right? So always use this cool warm. Okay, and center is equal to 0. Center means the mapping of all this, the page layout and all, which is equal to 0 means it will take a correct position, or else one map will be this side, one map will be this side. We are talking about heat map. Heat map is like a box. Okay, I'll run this, I'll show you like this. Okay, now it has come with a dark color. Okay, cool one. I don't want this, I'll take the default one. Okay, so it picks up default by itself. Okay, now this looks good. Okay, so you can see here the correlation. What it does is study hours 1 hour. Okay, and marks 0.98. Okay, and attendance 0.98. Okay, now here what we can how we can interpret here is diagonal you have to see. Okay, so marks is strongly correlated with both study hours, okay, study hours and attendance. Okay, so that is what we can make out. Okay, study hours, marks. Okay, this is how you have to interpret. And wherever you see the weak correlation, that indicates independent independence between variables. Okay, now we'll do the facet grid. Okay, so facet grid is the function that you will, that is part of your cbond c sns dot facet grid df. I'm passing here column is equal to gender, a common, and row is equal to string. Okay, and then I am mapping map underscore data frame sns dot scatter plot study hours and marks. Okay, I'll run this, then you will understand how it looks like. Okay, now you see marks, okay, and marks. Okay, now you see the difference here is stream is equal to commerce. Okay, gender is equal to male. Okay, and here the first second one stream is equal to commerce, female. Okay, so we are bifurcating between different stream. Okay, this option. So this formula, I mean this code will give you some analysis for your data. Okay, marks now. It is very linear. Okay, so commerce, gender male. So they are topper, but most of them are average, you can say. Okay, wherever you have a density here, okay, you can say 70 to 80% average. There is one guy who has scored 90 and above, but most of them are here. Okay, and female, none of them are there because nobody is has taken this science, sorry, commerce stream here. Sorry, this is science, right? This is the heading for the, yes, science male and this female, and this is blank, nobody has taken here. If you see our data set, original data set, okay, one female is there, female arts, this one commerce, this one commerce, this one arts. So there is no one in science. That is the reason we are getting here as empty. Okay, so don't think, I mean, something is wrong here. Okay, just because the data itself is designed in such a way that it is giving a blank output. Okay, now commerce. So there is one person male, rest of the males are in science stream. Okay, commerce, there are two female. Okay, you can see here average 70 to 85. Arts, okay, there is only one male in arts and he's an average guy. Okay, somehow he's making able to making to pass out by scoring 65%. And here female, two female, this is close to uh, 84. Okay, and this one is 90, so you can say 80 to 90. Okay, makes sense, guys? These are very important. Okay, so I'll add one more. Okay, this is facet grid. Okay, this is the same thing. You can do a lot of things. There are a lot. If you go to the documentation part of CBOT, you'll get lot of visualization techniques. Okay, I just picked up today. Okay, this code itself is very big. If I type this, my 20 minutes will go away. So okay, so that's the reason. What I've done is I have ran this and saved it in a notepad so that I can show you. Okay, always keep all this code intact because you never know when you need what. Okay, so this is 3D for scatter for study hours, marks and attendance, all numeric data. Okay, how it is flowing you can see here. Okay, study hours, if someone is studying 2 hours, okay, more, and if it is more, okay, and 4 hours means the score is close to 90%. Okay, so this one is this. Okay, between 5 to 6 hours if you are spending, you can see you can score about 90. So this is a 3D uh, uh, I mean 3D depiction. Okay, so it will give this, sometimes it will be useful for numeric. Okay, categorical and all you cannot do. Categorical you have to do a count plot, hist plot and all those. Okay, you can use this also. Okay, now I'll talk about PCA. Okay, PCA stands for Principal Component Analysis. Okay, now what does it help? PCA reduce dimensionality. Now what is the dimensionality? Okay, say for example you have 100 columns. Okay, in Excel sheet you have columns, 100 columns, and you have rows, 10,000 rows. Okay, now for your analysis you might not need the entire column, right? So PCA will help reduce the dimensionality. Okay, if you have many variables you will have fewer components. Okay, and by reducing PCA, what it will retain is, it will retain maximum variance, the difference between your mean and actual mean. Okay, standard deviation. Okay, and reviewing, and also it also reduce the multicolor multi, there is one term what it does. Right, there is one terminology. Okay, PC. Okay, now you see how PCA works is, you have, just assume you have different colors here, yellow, red, blue, green, lot of colors are there, right? Okay, you see here, right? Now here what PCA does is, after you convert your entire data, it will pick only three column which is required for your analysis. That is the beauty of PCA. Okay, so I'll just take this image and I'll put it here. Okay, this is a very good. Uh, okay, I'll run this. Okay, how PC works, this is the example. Okay, I'll just run this. Multicollinearity. Okay, yeah, there should be one more definition for it. See, if you read all these things, right, you will become expert, definitely, but you need to understand what it does, basics. Okay, the terminology. Yeah, advantage. Okay, no, noise, we also say sometimes noise reduction. Okay, data compression, outlier detection, multi-collinearity handling. Okay, these are the, yeah, these I forgot. Noise reduction, data compression, and outlier. I'll just copy this anyway. I'll just put it there. Okay, these points I was looking for. Okay, advantage of principal component analysis. Okay, multicollinearity, noise reduction, data compression, and outlier detection. Okay, so what it does, first function creates new uncorrelated variables to address issues when original features are highly correlated. Eliminates component with low variance, enhance data clarity. Okay, data compression, represent data with fewer component, reduce storage needs. See, for, yeah, this is very good point. If you have a data set which is 5 GB or 10 GB, okay, because you have 100 columns, okay, but you don't need 100 columns for your analysis. What PCA will do, it will tell you after the analysis how many rows, how many columns are required. If says only 6 or 7 columns is required for this analysis, it will store, it will save your storage as well. Okay, that is what it means to say reduce storage needs, because when you run all these things on cloud environment, right, you are charged for each and every data that you are storing on the cloud, okay, in MB or in GB or in TB. Okay, outlier detection identifies unusual data points by showing which ones deviate significantly in the reduced space. So this one function, the PCA will take care of all these 4 points. That is a beauty. Okay, so the formula is the code is big here. Okay, don't worry about the code. Okay, what you need to understand here is, okay, this line. Okay, selecting only numeric features. See, like I said, all these languages or all this machine learning, deep learning, okay, it can perform only on numeric value. Okay, it cannot perform on categorical. It will throw an error. Okay, and then there's a formula, and you get the output. Okay, after this is done, you can see it will create its own data frame, and then it will show you the result. Okay, so first what I'll do is I'll type df, we'll see the before and after. This is my data. Okay, okay, after this is done, let's see how our data looks like. Okay, now you see PC1, PC2. Okay, PC is the title that it is adding by itself. Okay, principal component 1, principal component 2. Okay, for male, female, male, female, male. Okay, so this is the number that you see here on the right hand side. Okay, so it combines correlation, correlated feature into PC, principal components. Okay, and it also points close together. I mean, across whichever the variables are close. Wherever you see minus, okay, so this is rejected. Okay, this one, okay, 0.06 minus 1. Okay, this is zero point 0.8 minus zero point 0.2. It is negative. Okay, this is negative, but we can also visualize the same result by scatter plot. Okay, scatter plot we have already done. So I'll just add this code for your learning to, okay, now you see here, male, female we have, okay, principal component. Okay, now you see here, these are all male and female, it's all scattered here and there. Okay, so here two values are scattered. Okay, I have one more chart, I'll add it. Okay, this is pair plot, pair grid, sorry. Okay, pair grid. Okay, so these you see here, this is the combination of marks. Okay, and this one is marks, and this color code that you see, amber and blue, represent gender. Okay, female and male. Okay, now here you see study hours. Okay, female are anyway less. Okay, so they are study hours, you see here, somewhere 2.5 to 2.5 to somewhere 6.7 or somewhere. Okay, so that is the average they are studying. So if you see the male students here, they are less. Okay, but at the same time it is also increasing. Okay, so it gives you a good insight about your data. Okay, it combines multiple visual layers. Okay, all these are visual layers for expert analysis. When you get your data right, you have to sit. Okay, you cannot just see and go. You have to sit one by one and you have to interpret marks. Okay, so if it is going like this, okay, so what does that mean? You can see male are dominating in marks. Okay, 90 and above. Okay, here study hours. Okay, study hours, a male only here also, so it comes close to uh, this line, right? Close to 6.5 hours. Okay, 6.5 or 6.5 something. Okay, and bar plot shows. Okay, so it starts from 4 hours minimum. Okay, 10 hours. Okay, and we have this one 4, and there's a combination of 4 and 10 hours. Okay, that is how you have to interpret. And this is attendance. Okay, last one is attendance. Attendance, who is there perfect? Male. Okay, here also. Here 90% and boys 80%. Marks, okay, attendance and marks, okay. So is there any correlation with attendance and marks? No, I don't. But study and marks, yes. There's a strong correlation with study hours and marks. Okay, so you can see here, and this is the attendance one. So 90% are female who are attending, the percentage of attendance and marked, and the 80% are uh, male. This is called pair grid. Simple, this is simple guys. Okay, so this is a one variable I created. Okay, so different visualization has different way to uh, add the parameter within this braces. Okay, df, somewhere you have to say data is equal to df. So I mean, if you keep this right, I just keep these type of sheets all the time. Okay, whenever I want to create, I'll just open. I'll only thing is I'll change this. Okay, and this rest I'll keep it. So code, if you understand, you can play around with different data set as well. Okay, so let me run this. This is one of the other plotting methods. Okay, so pandas has a inbuilt plotting method which is called parallel coordinates. Okay, these are all parallel coordinates, and you see study hours has a strong this thing. Okay, relation with marks. Okay, attendance I don't see. Okay, female, these two lines, one, two, three, four. Okay, and this is great for comparing multiple numeric variables grouped by categorical. Okay, here categorical, what is the categorical I'm using here? Gender, hue here. Okay, color is equal to blue and orange for identifying this gender. Okay, and this is title, this is other one. Clear guys? Okay, but yeah, but practice is required guys. Okay,
Yes, friend.
see, don't worry about the code and all, you'll get lot of codes in the internet, but if you know when to use what, just copy paste, change here and there the data values and then you can represent those. Okay, pair plot, quick of all numeric relationship. This is the formula sns dot pair plot, if you have seen there before. Okay, and heat map, how do you do? Sns dot heat map, visual correlation matrix. Okay, correlating with different variables. Facet grid is compares across categories. Okay, categories, we have seen this. And 3D plot is shows the three numeric dimension for three values like marks, study hours, and attendance. Okay, and PC is dimensionality reduction. Okay, and feature extraction. Okay, so it will reduce if you have columns, a lot of columns, like in real-time production data, right? You will see columns close to 300, 400 columns. But you have to, when you have to do the analysis, you will get confused where to start. Okay, simple solution is PCA, principal component analysis. If you do this more than enough, it will give you the slip stream version of your data, and you can perform those data analysis. Okay, so these are the things. Okay, so uh, you can stop the recording. Okay.